Hello and welcome back to the Master Civil Engineering, and in this video we will learn that how to find the centroid of any composite shape. I have been given a composite shape and we have to locate its centroid. You can see the composite shape. Okay, we have to find the centroid of this shaded blue portion only. Okay, so from this shape this circular portion has been cut out and we have to find the centroid of the rest of the shape. To find the centroid of this shape, we will divide this, that is this composite shape, into four geometrical figures. Okay, so you can see that I have divided this composite shape into four geometrical figure. The first one is the rectangle, second one is the large triangle, this one, then third one is the small triangle, and finally this circle. And I will find the centroid of each of these geometrical figures, and from that we will locate the total centroid of the composite shape. So to find the centroid of any composite shape, you have to divide that shape into possible geometrical figures, find the centroid of each geometrical figure, and then you have to use the equation to find the centroid of the composite shape. So first we will find the centroid of this rectangle. For this, the rectangle area, this is width multiplied by the height. So width of this rectangle, this is 120 mm, and height of this rectangle, this is 40 mm. So it will be 120 into 40, which is 4800 mm square. X coordinate of the centroid. So x coordinate of the centroid, this is always measured from the y axis, and y coordinate of the centroid, this is always measured from the x axis. So x coordinate of the centroid, that is x coordinate of this rectangle, this is the centroid of this rectangle, and centroid of the rectangle is, you know, that centroid of the rectangle is half of the either the length or the half of the width or the height. So for this rectangle, if you are measuring the x coordinate of the centroid, it will be at a distance of half of the width from the y axis. Okay, because one edge of the rectangle, this is coinciding with the y axis, so centroid of this x coordinate of the centroid of this rectangle, this will be half of this 120. Okay, because it will be located somewhere here, that is 60 mm from the y axis. Similarly, y coordinate of the centroid, this will be measured from the x-axis, and it will be again half of the height of this rectangle, because again one edge of this rectangle is coinciding with the x-axis, so it will be half of this height, that is 40 mm. So it will be 40 by 2, which is 20 mm. So x coordinate of the centroid of the rectangle is 60 mm, and y coordinate of the centroid of the rectangle is 20 mm. Similarly, for large triangle, its area will be half of base into altitude. So half of base for this rectangle is 90 mm, and altitude for this rectangle is 60 mm. So it will be one half of 90 into 60, which is 2700 mm square. X coordinate of the centroid, this will be measured from the y axis. We know that the centroid of the triangle, this is, if you have to measure it from the apex, it will be 2h by 3, and if you have to measure it from the base, it will be h by 3. We have to find the x coordinate. You can see for this triangle, this base, this is coinciding with the y axis, so this apex is coinciding with the y axis. So x coordinate, this will be 2 into 90 divided by 3, that is 2 into the side which is perpendicular to the y-axis, which is 90 mm, divided by 3, which is equal to 60 mm. And y coordinate of the centroid of the triangle, so centroid of this large triangle, this will be located at h by 3 from its base. Okay, because if we are measuring from the base, okay, in this direction, that is in the perpendicular to the x-axis, it will be h by 3 from its base, which is 90 mm, and height in this case is 60 mm. So it will be h by 3, 60 by 3, plus you have to add this distance, that is this side of the rectangle, which is 40 mm. So it will be 40 mm plus h by 3. So 40 mm plus 60 by 3, which is equal to 60 mm, is the y coordinate of the centroid of this large triangle. So x coordinate of the centroid of this triangle, this is 60 mm measured from the y-axis, and y coordinate of the centroid of this large triangle is again 60 mm, and this is measured from the x-axis. Similarly, for small triangle, its area will be again half of base into altitude. So base, because the total that is total side of the rectangle is 120 mm, and the base of this large triangle, this is 90 mm. So base of this small triangle, that is this side, this will be 120 minus 90, which is 30 mm, and height of this small triangle, this is 60 mm. So area will be 1 by 2 into 30 into 60, which is 900 mm square. After that, x coordinate, this will be measured from this y-axis. Okay, so it will be 90. Okay, 90 plus, that is, first you have to this distance, take this distance, which is 90 mm, and then plus h by 3, or the side divided by 3, and in this case we have to take the distance which is perpendicular to the y-axis. So we have to take 30 divided by 3, because base for this triangle is 30. So centroid x coordinate of the centroid for the small triangle, this will be 90 mm plus base divided by 3, which is 30. So 90 plus 30 divided by 3, which is 100 mm. Similarly, y coordinate of the centroid for this small triangle, this will be first this 60 divided by 3 plus 40 mm. Okay, because we are measuring first the centroid from the base. Okay, so it will be 60 divided by 3 plus 40 mm. So it will be equal to 60 mm. Always remember that if you take the centroid of the triangle, if you take it from the apex, it will be 2h by 3, and if you take it from the base, it will be h by 3. In our case, we have to take it from the base, so it will be 60 divided by 3 plus this 40 mm. Okay, which is equal to 60 mm. After that, the centroid of this circle, okay, first the area of the circle, it will be pi r square. Radius of the circle is 30 mm, so it will be pi into 30 square, which is 2827.43 mm square. X coordinate of the centroid, this will be equal to, this is given in the question, that is the center of the circle. This is located at a distance of 70 mm from the y-axis. So x coordinate of the centroid is 70 mm. Similarly, y coordinate of the centroid, this is here y4. Okay, this will be equal to 40 mm. Okay, because the y coordinate of the centroid, this is because the this center of the circle, this is located at a distance of 40 mm from the x-axis. So y coordinate of the centroid of this circle, that is y4, it's 40 mm. After finding the centroid of all the geometrical figure, now you have to use the equation. So x coordinate of the centroid of the shaded area, this will be given by this equation, that is a1 into x1 plus a2 into x2 plus a3 into x3 minus a4 into x4 divided by a1 plus a2 plus a3 minus a4. I'm subtracting this that is a4 x4 from the numerator and a4 from the denominator, because this circle, this has been cut out from this composite shape, and we don't have to include this. It will not count in the centroid for this composite shape. That's why I have to subtract it from the total centroid. Okay, centroid area. So first you are finding the first you are taking the area into centroid for the whole composite shape, and from it you are subtracting this circular portion. So that's why I have taken minus a4 into x4 in the numerator and minus a4 in the denominator. Putting value, so it will be 4800 into 60 plus 2700 into 60 plus 900 into 100 minus 2827.43 into 70 divided by 4800 plus 2700 plus 900 minus 2827.43, which is equal to 61.4 mm. This is the x coordinate of the centroid of the shaded area measured from the y-axis. Similarly, y coordinate of the centroid of the shaded area, this will be given as a1 into y1 plus a2 into y2 plus a3 into y3 minus a4 into y4 divided by a1 plus a2 plus a3 minus a4. Putting values for a1 y1, a2 y2, a3 y3 and a4 y4, we get the value of y coordinate of the centroid for the shaded area as 35.7 mm. Okay, so the centroid of the shaded portion, this is equal to that is x coordinate is 61.4 mm and the y coordinate, this is 35.7 mm. Okay, so if you have to find the centroid of any composite shape, simply break the shape into simple geometrical figures, find the x coordinate and y coordinate for each of the separate figures, and then apply the equation for the total centroid area, and you have to see that which shape you have to add and which shape you have to subtract to find the centroid of the composite shape. I hope this solution video was clear and effective and you learned something new from this video. If you still have doubts, you can write them in the comment box and I will be happy to help you. Thanks for watching my videos and stay tuned.